Okay, so I'm going to skip 3 and I'm going to go to 4. Okay, so 4 times 4 is 16. And that's fine. And that's it. That's what I found. Okay, because I can't go any further than that, because once you get to the same value on each side, or the same digit on each side, or if it's more going to be more than that, then you're done. Okay, let's look at 20. So I go, okay, 20. So 1 times 20 is 20. We have 2 times 10 is 20. 3 does not going to work here. And so I'm going to go 4. 4 times 5 is 20. Okay. And then and 5 times 5 does not work. 6 times, so I'm done. So let's look at our common factors, right? Because that's what we're looking for here. We're looking for the greatest common factor that these two numbers have in common. So when we talk about GCF, you guys, right? Greatest common factor, we're talking about what's the highest number that these two guys have in common. And once we find that, we can divide. Okay. So the greatest number that these have in common, yes, they have 2 in common. I know you might say, well, we can use 2, but no, we want to go for the highest number, because if we because that will take one less step. If you go with a lower number, it's not the end of the world, but what's going to happen is you're going to find yourself having to reduce or simplify more time. So you'll have to do it by, you'll have to reduce by, you have to divide by 2, like probably 2 or 3 times before you get what you need, right? But here I'm going to check the greatest common factor, and the greatest common factor is 4. That's the 2 that's the C, right? That's the common, right? So now I'm going to say, all right, so 16, we can divide each of these by 4, because that's what they have in common. Now, if you're familiar with your multiplication tables, if you're pretty good, if you got it up here, that's cool. Then this is, you could probably do it faster. But for those of you who don't know how this works, right? Who want to know, well, how the heck do I find that common number? Well, this is one of the ways we can find that common number, right? Let's see. Another way is, check your multiplication chart. That helps too. Okay, so we're going to take 16 divided by 4. That is going to give us 4. And then we take 20 divided by 4, and that's going to give us 5. And so we have reduced 16 twentieths to 4 fifths, and we cannot go any lower than that. We can't simplify anymore than that. So that's kind of how we do, okay? Or at least, that's how, Aztec has you do it. Like I said, there's a couple of ways we could do it, but that's one of them. Okay. So this week we're going to continue on to fractions. So in this case, we are going to raise fractions, right? So the first way we divided, but let's say we need to raise fractions, and that's going to become really important, especially this skill is going to become really important for when we have different denominators when we have to add fractions with different denominators or subtract. Because this is the skill that we're going to use to make the denominators the same. Okay, so, as you go into this lesson, if you haven't gone in here yet, do take close attention to that. Okay, so raising a fraction to a higher term means finding an equivalent fraction. Oh, I forgot to do equivalency, right? So really quick, my bad. So if I wanted to find out if that was the same, if I wanted to find out 16 over 20 was the same as 4 over 5, I can just cross multiply. So I'm going to multiply 6 times 5 and 20 times 4. So 20 times 4 is 2 times 4 is 8. So that's going to be, and then add a 0. That's going to be 80. And 16, I believe 16 times 5, you'll probably get 80 also. So it should be the same. Okay. That's how you know something is equivalent. All right. All right. So going back into this. So what we're going to do is we're going to take 1/4 and we're going to raise it to a denominator of 20, right? And we're going to think to ourselves, well, what number should we be multiplied by 4 to get 20? How did we get to that? Right? So we're looking at denominators here, guys. So we're saying, okay, what number did we have to multiply by 4 to get that 20, right? What did we have to do? And then that the numerator, well, we don't know exactly what it is. Right? Now, so according to the tip, it says to find the number that should be multiplied by 4, we can just divide. That's probably the easiest thing to do. So if we know that 20 divided by 4 is 5, there we go. Ta-da! Right? So we multiply both the numerator. Once we get that missing factor, right? So, okay. Let's work the example because it's getting away from me a little bit. So we have 1/4, right? And we want to raise that. Once again, being the optimist, I know that at the end of this, I'm going to have a denominator of 20, right? Get into the habit of that. If you know what your goal is, if you know what your denominator is going to be, just get it out of the way, write it down, okay? So I'm going to say, okay, well, 4 times what is 20? Well, I know that's 5. So then what I'm going to do is I'm going to do the same thing. I'll multiply the top also times 5. And 1 times 5 is 5. It's going to give me 5/20. Now, if I want to see if those are equivalent, I just need to take 1/4 times 5/20. So 5 times 4 is 20, and 1 times 20 is 20. There you go. They are equivalent, so that works. So any questions here? Okay. Well, it rained. Like it totally rained this morning. Like weird. Not only was it rain, it was like cold rain. So it's like not used to that yet. Okay. So we have 1/6, and we know what our denominator is going to be. So we just got to determine what number did we have to multiply. So remember, the first step is to divide the denominators, and then you should be able to get your missing factor, okay? So I'll give you guys a moment to work that out. So if you're here with me, you can just work it out on your computer. If not, you can do this on paper. If someone wants to chime in with an answer in a little bit. Oh, by the way, you can write fraction answers. There's a couple of, pardon me. There's a way we can do that in the chat. So what we do is we put write a number, right? And then the key with the question mark. Now, if you're using your phone, you actually have your own separate key for this, but on a keyboard, you're going to put the slash, right? So you're going to write the slash, and the slash, this symbol, right? So this right here, the slash, right? And then you're going to put the number. So I'll show you what that looks like in the chat. So there's an example of how you can represent a fraction in the chat. That's fine. When I was younger, actually, like in our textbooks, that's how a lot of fractions were represented, like that. So if you got an answer for me, if you want to work that out, you totally can. Okay, so let's take a look at this. So what we're going to need to do here is, we can find our answer, right? I'm working, so I'm going to work this, and then we'll check if it's the same thing. So what we're going to do here is we're going to take 1/6, right? And I'm going to say, okay, well, I know I'm going to put my equation here that the denominator I want to get to is 18. Well, how did I get to 18? So I have to figure that out. I can divide. I can take, I take 18, right? And I can divide it by 6, right? I could do that, and that's fine. Or if I'm familiar with my multiplication table, I can, kind of pull that out. So I say, okay, well, 6 goes into 8. 6 times 3, I believe it's 3. So 6 times 3 is 18, and so I'm going to do the same thing to the top. So 1 times 3 is 3, so it should give us 3/18. Okay, so let's try that. There we go. And of course, if you wanted to check, you can cross multiply. Okay, we look at the explanation, and that'll give it's Thursday, sorry. That should give us an explanation, right? So if we cross multiply it again, we take 1 times 18, that gives us 18. 6 times 3 is 18. Those are very equivalent to each other, so that works, okay? And then I'm going to leave this next skill check to you guys. Okay. So when we're comparing fractions, right? So think of those symbols. That looks like it looks like an emoji. Recall those symbols right here, right? That's the greater than and the less than symbol. Okay, so that's greater than, that's less than, and that's equals. Right? So you wrote these symbols between the two numbers to show how the value of the numbers compare, right? You can use these symbols for comparing fractions. They do give you like a little review right here, right? So when comparing the two fractions with the same denominator, the fraction with the greater numerator is the greater fraction, right? So let's take a look at this. So think about our ice tray. For those of you who were with me yesterday, you're right, we talk about fractions like we talk about ice trays. So let's say we have 2 ice trays, right, in our freezer, and they're the same size, which is good. If they were different ice trays too, we could not do it, right? We couldn't add them up. And let's just say, let's take a look at the ice trays. We say, okay, well, which one has more ice in it? Well, each ice tray has 8 spaces in it, so that's our whole, right? 8 is the maximum that we can have, so that's going to be our denominator, right? And so our ice tray is in 8 sections, 8 parts. Now, how many of those are filled with water? Well, the one on the top, only 3 parts are filled with water. And then on the last one, we have 5, right? So that's pretty easy. We can plainly see, because they're the same thing, right? They're the same size ice trays with the same amount of spaces, that we know that the one with 5, filled 5 filled spaces is the one that has more water, right? Now, let's say we wanted to compare these two, right? What if we wanted to, okay, because now we got different denominators, right? So let's compare that. Give me a second. Sorry about that. I'm just making sure I didn't skip anything. Any questions? So while I'm waiting for this to kind of reload again, any questions here? Any questions here? Like I said, for those of you who haven't gotten into fractions yet, all this I think is really useful, as I'm going through this with you guys. Cannot stress how useful these ideas are to understanding how fractions work, and not only how fractions work, but the stuff that you're going to have to deal with like later on. Like in last Thursday, like when we were doing conversion ratios, we were using a lot of these same concepts in that we use for fractions and division to deal with conversion, right? There was a continue. Okay, so what we're going to do is we're going to compare 3/4 to 2/3. We're going to cross multiply, right? So we take, I'm going to work the example here, okay? So this is how I follow along. If I just look at it, my eyes are going to glaze over. It's Thursday. My brain is oatmeal right now. So I want to make sure I'm paying attention and that I'm kind of retaining what I know. Or what I've learned, sorry. So I'm going to say, okay, so I'm going to take 3 over 2 times 3. I'm going to cross multiply. So 4 times 2 is, so 4 times 2 is, so yeah. Okay, 4 times 2 is 8, and 3 times 3 is 9. Okay. So, I see. I see what they want us to do. They don't want us to cross, they don't want us to make another fraction here. So this is once again my Thursday brain. So what they want us to do is they just want to see which one's bigger, right? So we're comparing, we're not seeing if they're the same. Well, we are, but let's take a look. So we have 3/4 and 2/3, okay? And so we're going to take 4 times 2, or we're going to take 3 times 3, all right? That's going to give us 9. So 9 is the numerator of the first fraction, okay? And then we take 4 times 2, that's going to give us 8. 8 is the numerator of the second fraction. So let's kind of look at the results here, okay? Since we know that this 9 right here is greater than 8, then the first fraction is going to be greater than the second fraction, okay? So let's take a step back here because they're giving us a way to do this, okay? So once again, we have 3 over 4, right? And then we have 2 over 3. And we're going to say, okay, we're going to start in this direction. So I wish they would just have us do that. So we're going to start with this one direction first. And we're going to say, okay, 3 times 3 is 9. Okay, so that's going to be the numerator, that's fine, of the first fraction. And then we're going to take 4 times 2, and that's going to give us 8. So now we're comparing 9 and 8. And so since 9 is greater than 8, but what the heck does this have to do with our fraction? So just remember, this right here, this first number is equivalent to that one. And this number is equivalent to this one, right? So just kind of keep those things in mind. So, when you're comparing fractions like this, just make sure you're doing it in order, okay? Okay. All right. Let's see where we are for time. Okay, so here they want us to compare. So we'll do the skill check together. So work in the example, okay? So we're going to take 5 over 9. And we're going to take 8 over 9. Now, once again, I'm kind of keeping track of what I'm doing here. So I'm going to take 5 times 9. That's going to give me 45. So 45 is going to be the first numerator, okay? And then, so 45 is going to go to this one right here, okay? And then I'm going to multiply 9 times 8, and that's going to give me 72. And 72 is going to go to this one right here. So I figure out, okay, well, what's the bigger fraction? Well, just looking at this, we can tell that 72 is the bigger one, right? So we know at the end of the day that 8 over 9 is going to be greater than 5 over 9. Now, remember how I said yesterday or last week, I said, try not to do the alligator thing. Like the alligator wants to eat the bigger number. What I like to tend to use, because I think it's a little easier in the long run, is think of it as an arrow, and you want to say the arrow points to the smaller number. Okay, so if you think of it in that way, I think it would probably be a little bit easier to remember than alligator wants to eat the big one, right? So let's check our answer. Yep, and that's correct. All right. So let's look at our explanation here. Once again, it is, less than. So as I was as we were doing this, right? Now this one was a little easier because, well, it supposedly had the same denominator. So it had the same denominator, and we could have done it like that too. I mean, but we're not always going to have the same denominator. I mean, this one was an easier one because if they have the same denominator, you just like what number is bigger. But I use that cross multiplication one because I'm tired and I totally forgot. I could just, just line up. If they have the same denominator, I could just figure it out that way. But this is actually good practice because I was able to solve this by cross multiplying, right? And I kind of got the same result. So it's kind of good to look at it that way too. Okay. Skill check, same thing. This one they're giving you different denominators, but once again, just when you cross multiply, make sure that you assign the number to the correct fraction. Okay. Okay. Skill check. Yeah, review. Okay. So we're actually finished with this one. So remember, guys, really quick, fraction is a part of a whole. When a whole is broken into equal parts, the parts are a fraction of a whole. Fraction is written with one number over another number. Top one is called the numerator, bottom is the denominator. Remember, we also talked about what a proper fraction is. So fractions like the ones you see here are proper, meaning that the numerator is lower than the bottom number, right? And just remember, all fractions, like proper fractions, are less than 1. that's so. Remember when we were dealing with fractions, proper ones where the number on top is smaller. They're all numbers, small numbers, right? Because they're all less than one. So it's something to think about. Okay, guys, and that's the lesson. Okay, so we're gonna go into HiSET. We're gonna take a little bit of a breather there. Going into next week, so I'm actually gonna start reminding you guys, because today is October 31st. This is the last day. It's the last day of October. Oh my gosh, we're almost so why? All I can think of is the holidays are coming up, and I'm like, oh my gosh, it's no. It was so busy. Anyway, just as a reminder, not next Monday, but because next week is normal. Okay, so we have a normal week next week, but Monday the 11th, and you can write this down if you like. So you know in advance, and you should know this because it's probably going to be the same if you have kids in school. So just remember that Monday, November 11th, so 11/11. That's Veterans Day. And Veterans Day is a holiday where, remember, so Memorial Day, we actually use history, quick history lesson. Memorial Day is on the end of May. It's usually the last Monday in May. We celebrate those who died in war, right? So anybody who's fought in, any of our conflicts, like in Iraq or Afghanistan, or who fought in the first Gulf War, or in Korea, or Vietnam, or the World Wars, First, Second World War, even going back as far as the Civil War, right? You know, but Veterans Day is usually to celebrate those who served in the military, both living and dead, right? So veterans, past and present, even if they never fought in the war, like I have, like the only, like my grandfather he served in the military in airborne. He was in the airborne division. But basically, the airborne are the people that like jump from airplanes and land in enemy territory. Like that's what airborne they do. Um, but he never saw war because the war ended before he got deployed. But that's what he was training for. My father was in the military for 30 years, something like that. Um, and so he would be considered a veteran, even though he never participated directly in war. He's still a veteran. My brother, he served in the U.S. Army also for about 20 years, and so he is a veteran also. So that counts. So just to kind of keep aware of what why that's a federal holiday. And what it's about, because it is a little different than Memorial Day. Okay, so just know that that's going to be a holiday, and that is coming up in about. So we got like a 4-day weekend coming up, okay? Because we're not going to see each other for a bit. Okay, let's go to HiSET. So we're going to start. Yes, last week we looked at conversion, right? How to convert. Now, if you're not sure about, please take a look at that video. I think the video went really, really well in explaining what conversion ratios were, and we are going to see them again. So do take a look at that recording. because I thought it was a really good lesson on, explaining, how that works. So anyway, so I'm going out of pre-GED and I'm going into HiSET math. So I'm going into the high level, the highest level here. I'm going to go into geometry, and we're going to look at angles today. We're going to at least going to start. We might finish it. The next couple of lessons are fairly short. Like this one right here, this one on angles, this is only like 8 slides long. So a lot of this is vocabulary. So the next lesson or two is mainly about vocabulary and identification. There was not going to be too much in the way of like hard math. We just need to be able to start knowing what we're talking about. So in this one, we're gonna look at angles, and we're gonna identify different types of angles, right? And also identify different types of triangles. Like we're gonna identify triangles. It's like we're back in like kindergarten again, kind of, kind of. Okay. So angle, when you think of angles, right? What do you think of, right? Maybe nothing. Maybe you don't even think about angles in your everyday life. That's okay. Depends on what you do for a living. If you work in construction, you might be thinking more about angles. If you ever played a sport that involved hitting a ball, you might be thinking about angles, right? Like golf or baseball or tennis, right? Or even volleyball, right? But outside of that, maybe it's something we don't think about too much. Okay, maybe driving, we might think about angles. Okay, so what is an angle? Okay, so an angle consists of two rays that share the same endpoint. So that endpoint is called the vertex. So this is prime note-taking time. Because we are not doing a lot of examples, like a lot of math examples, but a lot of this is identification. So we got to write down, make sure we're writing down our vocabulary, okay? Because at some point we're going to have to learn how to measure these things. So first of all, what is a ray? Okay, now for those of you who are in pre-GED, that's probably going to be, you're going to learn what that is, but just to review really quick. So a ray, well, there's two things that we need to be aware of. First, a ray is, this is a ray, right? A ray, it looks like a line, but a ray goes on forever, okay? Tends to go on forever in either direction, okay? So this is an example of a ray. This is a ray. And of course, if I did it diagonally, that would still be a ray, okay? So that it just continues on and on and on and on and on, okay? Now, a line is different, okay? So a line is different. A line has endpoints, like it does end. So a line is usually a figure like this that has a beginning, has a point, an endpoint on both sides, on both ends. So that would be a line. This is a line. And that's a line. Okay. So just so we got that straight, okay? So that's the difference between a line and a ray, all right? Okay. Now, in this figure right here, we have two rays. These are rays. These do count as rays because this point and this point just goes on forever and ever and ever, okay? Now this ray, these two rays do share an endpoint, but they are still rays. It's not a line. So, okay. Now this part, this point, this endpoint that they both share, this is called a vertex. Okay. So that is called the vertex. So that's where they meet. Now, the rays, so in an angle, remember, we're specifically talking about angles. So the rays here, right, that one, this is called a side. So that's a side, that's a side, okay? There we go. Now, vertex, actually, if there's, if you're dealing with more than one, there's the plural version is vertices. That's how we pronounce it. Vertices, okay? So singular vertex, plural vertices. Okay. So let's go ahead and take a look at this. So any questions? Any questions here? Stop just for a moment. Okay. So now we know what an angle is called. What makes up an angle? Now this angle can be called angle ABC because those are the letters representing the two rays and the vertex that creates the angle. So so we can label it as angle ABC. Now, if the angle is named in this way, the center letter is always the same as the vertex, okay? So, for example, right? So what we're saying is here, if we're going to label, if we're going to name an angle, right? So let's, for example, let's say this was an ABC. Let's say this was X, Y, and Z. Well, remember, so that when you're writing the name of your angle, that Y is always going to go into the middle. So if I was to write this, I would use this symbol right here. So that means angle, okay? And this is angle X, Y, and Z. And because that, we always put the vertex in the middle, okay? Like that when we write it out, when we label it. Okay. Now, cool thing is we also can name it after we can name it after the vertex. We can just say call it angle B, and that would be okay too. And see, so here they're using the symbol, right? That angle symbol. Okay. So this could be labeled as angle ABC, or we can call it angle B. See, this one's not too bad, this lesson. Now, we're going to talk about two different types of angles. We're going to talk about acute and obtuse. So acute angles, right, measure less than 90 degrees. An obtuse angle measures more than 90 degrees. Now, don't worry too much about measuring right now, okay? We're not there. But you gotta think, okay, well, how do I know that this is 90 degrees? Well, if I were to use a tool called a protractor, right? And I'll show you really quick. You've probably had one of these maybe, or maybe you've seen one of these when you were in school. So if you have a tool called a protractor, right, you would use that tool to measure what, how wide, right, an angle is. So that's what you would use to determine that, okay? But don't worry too much about measuring right now. They oftentimes in this early on, they just do the measuring, they give you the measurements already. So don't worry too much. So what they're saying here is that the acute angle, and this is how they're representing it, there's that's so what they're saying is 0 degrees, right? So it's basically the acute angle is, well, more or less. So they're basically writing it in the mathematical version. So this little thing right here, that's a Greek letter. That's not a 0. So that's a Greek letter. But this is a way of saying this right here. So an acute angle measures less than 90 degrees. Basically, it's somewhere between 0 degrees and 90 degrees, right? That it's acute. Has to be less. And that does not include 90, okay? That does not include 90. So really, it's somewhere between 0 degrees and really it'd be 89 degrees. Okay, so somewhere in there. Now, an obtuse angle is more than 90 degrees. So as you can see right here, an obtuse angle, this little bit right here is saying that it's somewhere between 90 degrees and 180 degrees. Okay. Because once we get to 180 degrees, it's no longer an angle. Not really. We'll find out in just a moment once we get to that. So we have acute, we have obtuse. Okay. So in this case, okay, so let's move on. Oh, I missed the continue again. Here. They put the continue, they hit it. They usually have it at the bottom, but in this case, guys, they have the continue button on the side. That's just, yeah, they were like, it was in the middle and then it went boop, it moved to the, that's terrible. Now the last one, in case you miss it in the lesson, once you get 180 degrees, it pretty much looks like a straight line, okay? But because it's still an angle, because we still have a vertex in the middle, right? So, we still have that vertex in the middle, and we still have, these rays going out, right? We would call that a straight angle. A straight angle is 180 degrees. What's 180 degrees? Well, remember, when we measure angles, what we're measuring right here is the distance between the two rays. So that's how we determine angle, right? What is that distance, right? In this case, it's 180 degrees, right? Like if I did this, oh, it looks like I'm drawing a baseball field. Speaking of which, was anybody happy that the Dodgers won? I'm not a big baseball person, but I was raised in LA, so Was anybody up here happy about that? I don't know. Does anybody care? Okay, so that would be a 90-degree angle. And why is this 90 degrees, guys? Because if we measured this ray, the distance between these two rays, right? If we got a protractor, that we would see that that measures 90 degrees. Okay. All right. Okay, so skill check is pretty much, they're going to give you sets of angles. Notice that all of these angles share one vertex. So you have to pay close attention to specifically what angle they are talking about. In this case, we're talking about angle EBC. Now, our vertex, thank goodness, is always going to be B. Right? Our vertex is always going to be B. Now, but we're looking for BC or EBC. So I'm looking for E. That's one ray. And I'm also looking for C, and that's going to be this one right here. Okay. So just make sure, and I think I skipped one by accident because what we didn't talk about right angles. But right angles, if you know, if you go into this lesson, just know that right angles, this is a right angle right here. Right angles are special, okay? So remember how we said, you know, acute angles are less than 90 degrees. Obtuse would be greater than 90 degrees. Well, this right here that looks like an L, this is actually 90 degrees. And this is known as a right angle, okay? All right. Okay, so we're going to finish up today by talking about different types of triangles, okay? Remember, as we learned in kindergarten, a triangle is a shape, it's a polygon specifically, with three sides, and the reason why it's called a triangle is not just because it has three sides, it's because it has three angles, right? It has three vertices, right? That's why it's a triangle. It's less about the sides and really more about the angles, okay? Yeah, we classify a triangle by its angles, not its sides. Now, take a look at this. Now, there's different types of triangles. Now, when all three angles are acute, remember, acute is less than 90 degrees. So if you have a triangle and all the angles are less than, so let's take a look. So in this example, all of these angles measure less than 90 degrees. Like this angle right here is 81 degrees. This angle right here is 31. This one is 68, right? And so this is called an acute triangle. Now, obtuse angles are not as picky as acute. Acute triangles, all the angles have to be acute. But obtuse, not so picky, okay? Because in an obtuse triangle, one angle, all it takes is one angle. So when one angle in a triangle is obtuse and the other two are acute, then it's obtuse. For example, let's take a look at this. So this one, we have this, the angle down here, 121 degrees, measures more than 90 degrees. And the other two measure less than 90. So this is obtuse. Now, just know that it's impossible to make a triangle with more than one obtuse angle, okay? Just say it. You can't have two obtuse angles. I think after that, it stops being a triangle. It becomes like something else. I don't know. Okay, so now remember we talked about right angles a little bit. So when one angle in a triangle is right, like this one right here, and usually we signify this by that square in the corner, right? We put that square in the angle to show that it is 90 degrees. So if one of the angles is exactly 90 degrees, what's going to happen is that the other two angles measure less. So one angle is 90 degrees and the other two are acute, right? And so that would be a right triangle. So we've looked at three types of triangles. We've looked at an acute triangle where all three angles have to be less than 90 degrees. We looked at an obtuse triangle where we have one angle that is usually wide open, and it's more than 90 degrees, and the other two are less than 90 degrees. And then we have this right triangle where one angle is 90 degrees. And then the skill check, once again, is going to ask you if the triangle is acute, or if it's obtuse, or if it's right. So you're going to answer A, B, or C. This is more or less about your math ability and more about your note-taking ability. Because that's it. That's the lesson, okay? This is really about getting that vocabulary down and identifying it. Because when you do the drill, right, it's going to really depend on how well you took notes in the lesson. All right. Any questions? Any questions here? Because we are done. Any questions here before I hang up? If you are thinking about coming to the evening class, I will be there. That hasn't changed, and I'll be on at 7. So that hasn't changed. So if you're thinking about doing that, popping in, you totally can. Okay, guys. So with that, if you don't have any questions for me, I'm going to go ahead and hang up. You guys have a safe evening, and I will see you guys next Monday. Okay. All right, so take care.